Hello, this is Clint Halstead, and this is a MPLABX tutorial on how to use the simulator inside of MPLABX. So, I have a program here that I modified from a website from Tim Wilmshurst on a book called Designing Embedded Systems, and I'll show you the website. It's Designing Embedded Systems with PIC Microcontrollers, www.embeddedknowhow.co.uk. But this book is exercise 5.1, goes through this Bitset program, which is in chapter 5. So chapter 5 program example 5.1 code, you actually have to copy it from 4.5 and then modify it to get to 5.1. But here's the program I created. I modified the code. What this code basically does, and we're going to work on simulating it, is has two inputs, port A bit 3 and port A bit 4. And whenever that A and B, those are bits on the line, whenever those go low, it's going to set the corresponding port B bit to high. So when port A bit 3 goes low, port B bit 3 is going to go high. Now what we want to do, this is we're assuming that we don't have hardware yet, so we don't have really a way to test this in any physical hardware, so we have to just use a simulator program. Now so what we're going to do, so let's look really quick how the code works, and then I'll go over how we're going to simulate it. First off, you got this setup program up here, and then it gets down to this loop code, which this is just going to loop in real time. So the first instruction is bit clear F, port B 3. So the first thing it's going to do is it's just going to clear port B bit 3. Then it's going to do a bit test F skip of clear. Bit test F skip of set port A bit 3. So if this port 3, because there's a pull-up resistor on the hardware, there's going to be. We're assuming that your push button switch is going to have a pull-up resistor, and then the push button is going to, when you push the push button switch, it's going to ground that pin. So what that means is, you have a schematic with a pull-up resistor on that pin with a switch shunted to ground. So when we push that button, it's going to clear that. So what we're saying is, if it's a 1, we're going to skip this next instruction. That's why it says bit test F skip of set. So it should skip it if it's high. So if you have not pushed the button, it'll skip that instruction and go to the next one. But if you have pushed the button, then it's going to notice what it's going to do. Bit set F port B bit 3. And now this is in real time too, so it's assuming that it's going to take you about 1 second to push the button. So it's going to be the entire time you're pushing the button, it's going to be setting that bit. Now when you let go, it's going to clear it. That's kind of the way it's going to work. So it's a real-time operation. And then you have the same instructions for bit 4. So you have a bit 3 and you have bit 4. That's why you have the 4s at the end of these statements. So really this code here for the 4th bit is the exact same as the code here for the 3rd bit. Okay, and then it just says go to loop, so it's just going to loop forever. So let's try to simulate this and see how it's going to work. So the first thing we have to do is we have to compile our code. So we click this button up here that says clean and build main project. So if we do that, we should get no errors. And you say loading complete, and you say error 0, error 0. So looks like there's no errors. Then the next thing we do is we click this button called Debug Main Project. Click that button, and it should start running. And it is running, because you can see here that you have a stop button and a pause button. What that means is that the simulator is running right now, you just can't see it. So if you hit pause, you'll stop the execution. So it just happened to stop. It happened to be right here when we pushed the pause button. I didn't hit the stop button, I hit the pause button. Now if we want to reset this program back to the very beginning, we can hit this little reset button. It has the purple button with the 2 little arrows. Click that button and it goes to the start. Now what we can do is, notice that you have 4 orange buttons step over, step into, run to cursor, and set PC at cursor. So what we're going to do is, the most common one to use is really the step into. So step into just means you're going to step one instruction. So you're going to go to the next instruction. So that's represented by the orange down arrow. So if we hit that, if we click that, then it's just going to move to the next instruction. Notice it went from line 27 to 28. If we keep clicking that, then you can see it's going through our program. This is the initialization part of the program. If you keep clicking that button, you notice that it goes through the code and it loops. It just continues to loop. It looks like that's about right. We don't really know what's happening at this point. We just know that at least the loop structure, the go-to loop structure, seems to be working right. So in order to see what's happening, we need to add a watch window. Okay, so let's add a watch window. So we go up to Debug menu, hit Debug, and you say New Watch. Okay, New Watch. And okay, so how you're gonna have to add some things in here. So I'm gonna add the windows that I want. I want to have, let's see, I want to have the PC, the program counter. So I'll click that one. Now I have to hit the control button because I'm going to add multiple things. So I want to have port A and port B, okay, and the W register. So let's just add those 4. So that's how you do that. We wanted to do the special function registers, not the. You could do the global as well, but just to minimize. So okay. So now we have our watch window down here. Now we have to push. We have to push this button in order to see them. So you push that button, then you'll be able to see them. Now what I like to do is I like to drag this out. I like to drag it kind of off the screen. I'm going to drag it onto my second window that I have, and then I'm going to pull it back. So if you, let's just kind of show that again. You can, let's see here. Well, anyway, you can pull this thing off the screen. Makes it a little bit easier. You can pull it to, you can minimize this window and then pull it off to the side of the window, and it kind of detaches it from the inside of there. Now I have too much information here, so I have address, I have type. Only thing I really care about is the name and the value. So I'm going to clean this up a little bit. Click this button at the top right corner, change visible columns. I'm going to get rid of address, I'm going to get rid of type. Only thing I care about is I just want to see the value, and I want to make this window small. Okay. Alright. So I got the program counter. Looks like I have some of this stuff in here twice, so let me delete this. I think this information was from the last time I ran it. Okay, W register, delete. Okay. So I have the program counter, port A, port B, and the W register. So let's move this over here so it's kind of out of our way, not blocking the rest of the information that we have down here. So now you can see, as you start to step through this code, first you can see that the program counter increments each time. You can see that whenever something gets updated, it's going to turn to red. If it didn't update, then it just stays blue, or it stays black. Yeah, so you know that each time the port A is, or the program counter, each time the program counter is going to increment. That's because every time you hit step, it's going to increment that. The program counter is what keeps account of where you're at. So, for example, right now we're on 0F. So if I hit this, it's going to loop back to 09. So this is 09 in the flash memory. If I click it again, it goes to 0A. So it's just going to keep incrementing. Now we can at least look at port B and port A now, but now we have a problem with, well, how are we going to change port A? There's no way for us to change port A right now. You can see that over here port A is always all zeros. You know, so let's we need to have a way of setting port A, bit 3 and bit 4. So how do we do that? Well, we do that with the stimulus. So we go to Window, so click the Window button, go to Simulator, and then click Stimulus. And now down here what we do is we have a row here, and we have to set, let's set port A is RA3, that's what they call it, and we want to set it high. That's kind of the default. Now if we want to add another one, I also want to add a bit to make it where I can set port RA3 low. So I have to click Add Row, and then it adds another row, and then I click here, and then I click the same thing, RA3, and now I want to set it low. So the way it works is you have this little fire button. So when you want to set this port A high, you click fire. When you want to set it low, you click fire there. So that allows you to set port A high and low. But you have to have this little button up here running. And also notice it doesn't do anything instantaneously. You actually have to step through the code before it actually takes it. So let's hit port A bit 3 high. So I click the button fire, and then I click step. And you notice that port A bit 3 went to 1, and it's in red. That means that it changed. Now if I continue to hit that button, it's not going to change anymore. It's just going to stay it's just going to stay at 1. But now if I go down here and I click set low, then the next time I step, you can see it goes low. So that's kind of the way that works. So that's how you do a stimulus. So okay, so let's step through this code and see what happens. Okay, so right now, notice before, currently we have a port A, all of port A is 0. So if we go up here, it's going to be bit clear F, port B. Okay, you can see that port B is cleared. Okay. Now it's going to say bit test F, skip if set. So that means it's going to skip this next instruction if port A is set. But you can see over here, well, it's not set. It's actually a 0. So it's since it's a 0, then it should not skip. So let's try it. Okay, so it didn't skip. That's good. Now the next instruction says bit set F port B 3. So let's see. It should set port B to 1. Port B3, RB3, it should set to a 1. So let's see if it does. Okay, it set it to a 1. That's good. Now it does the same thing for port B. You can see here that port B, it's going to clear port B. So let's see. Okay, it cleared port B. Now it's going to say bit test F, skip if set, bit 4 of port A. But bit 4 of port A is a 0, so it shouldn't skip it. So it's going to, let's see what happens. It should set it. So it's going to set it. Okay. But let's hit the button and see if it sets it. Yes, it did set it. It set port B bit 4 to a 1. That's going to say go to loop. Okay, so go to loop. Okay, so that seems to work. So now let's set port. Let's set RA3. Let's set it high. Okay, now when we step, RA3 should go high. Okay, it did go high. Okay, so that's high now. But now it's going to say bit set F, skip if set. So this time it's set. So it should skip that. This next instruction should be skipped. So let's see what happens when we hit this button. Okay, so it did skip that instruction. So that kind of is proof right there that your program is operating properly. Now another way to test this out a little bit quicker is you can just go to the end of this loop and you can say toggle line breakpoint. So you want to add a breakpoint. That's a way to add a breakpoint. You can see here this little red square means it's a breakpoint. Now what is a breakpoint? That means that you can hit the run button instead of the step button. If you hit run, it's going to run until it hits that code and then it's going to stop. So it's going to go through here to here and then stop. So if I hit run, notice it stops here. Now if I hit run again, it's going to stop again. So hit run, hit run. So every time I hit run, it's just going to run through all your, it's going to go through this code really fast and then stop. And let's see if, that's a little bit easier way to debug, and I'll show you how. Now if we set, this is already set high, so that should keep bit 3 on RB3 should keep it low. And it is, it's keeping it low. RB3 is low. But now if we set RA3 low, then it should make RB3 go high. So let's see if it does. It did. See, RB3 went high. See? Now there's no change. Now we'll set this RA3 high, hit run, RB3 goes low. So that's proof that your program is working exactly the way you want it. So that is the quick two, and you can add more down here. You can add more rows. So if you wanted to, you could add a row for RA4. You can set it high, and you can add another row. RA4 set low. So you can add as many as you want. You can also save it. You can generate a SCL file. You can save it to SBS file or whatever you want to do. So that's about it. That's the tutorial for MPLABX. Just a quick overview. Thank you, and I'll see you for some of my other lessons on PIC microcontrollers. Thank you.